Hello, my name is Chris Hill, and I'm from the University of Colorado Boulder Craft Tech Lab, and I'm here to present the ThreadBoard, designing an e-textile rapid prototyping board. E-textiles is a field of embedded computing that enables creators to design and create textile computational devices. No longer are creators restricted by static terminals on printed circuit boards or breadboards. Instead, they are free to stitch freeform paths that can connect the microcontroller to other components. Our research identifies a key technique of traditional embedded computing that is missing from e-textile creation. This technique is the rapid prototyping of threaded circuitry during the initial design stages. Our solution to this problem is to develop an e-textile tool that allows for the placement of freeform circuitry, uses materials and components that are native to e-textiles, does not stifle creativity, is non-intimidating to novices, and is easily made at home. Over the past several months, we have developed a tool called the ThreadBoard, which is a magnetic breadboard designed specifically for the unique set of constraints creators face when fabricating an e-textile project. If you turn your attention to the middle top two pictures, the left was an early prototype of the ThreadBoard that served as the proof of concept that we can embed magnets into pre-existing microcontrollers easily, and that they would allow for an intuitive connection with magnets embedded into stiff felt. The main issue with this design was the layout restrictions. The ThreadBoard could only support one or two actuators or sensors, and also due to layout design, the user could not easily utilize all the adjacent pins available on the microbit. To the right is the current version of the ThreadBoard. This version was inspired by the initial user tests and insights gained from the previous iteration. This layout was inspired by the circular design of e-textile microcontrollers like the LilyPad Arduino and Adafruit Circuit Playground. This design allows for the creation of more complex circuitry as well as the implementation of microcontrollers and components native to e-textiles. On the bottom left is the ThreadBoard toolkit we've been developing. Due to the metals used in certain components like the vibration motor, LEDs, and stainless steel thread that you see in the picture, these components are attracted to the magnets embedded into the ThreadBoard. On the bottom right, we can see an example project called the Big Dipper, where several LEDs and stainless steel thread attach to a microcontroller to make the circuitry. Now imagine the LEDs in the Big Dipper project weren't turning on like you thought they would. If you're using the ThreadBoard, you'd be able to quickly identify, then rearrange components and wires to fix any circuitry errors until all LEDs light up. Without the ThreadBoard, you'd have to spend time sewing all the LEDs and the microcontroller to cloth, and if the LEDs do not turn on, then you would have to get scissors and disassemble your project, which no one likes to do and is always a bit heartbreaking. Now referring to the previous bullet point, how can someone easily make a ThreadBoard at home? Looking at the creation process on the top right, 1. We create an open source 3D design that anyone can 3D print or transfer to an SVG and laser cut. 2. We design the ThreadBoard so the magnets can be press fit. This eliminates the need for adhesive or other tools. 3. If you have a component that is not attracted to the ThreadBoard, you can fit press magnets into the component's pins. And 4. You are now ready to begin prototyping circuitry on your ThreadBoard. For future work, we are beginning user studies to observe how students prototype e-textiles with the ThreadBoard. We will also continue refining the ThreadBoard's design to give users the best e-textile tool possible. For acknowledgements, I'd like to thank the Craft Tech Lab at the University of Colorado Boulder, the lab that I've worked in for the past 3 years, the Atlas Institute at CU Boulder, where I'll be starting my PhD this fall, the Institute of Cognitive Science at CU Boulder, the Debugging by Design collaborators at the University of Pennsylvania, and a special thanks to my PIs, Ann Eisenberg and Mark Gross, as well as the other members of the Craft Tech Lab, Ariel Bloom, and Michael Snyder.